Hi children, Dilip Bhatnagar here again. Today we shall move ahead with integration by partial fractions, part 2. In the last video, that is integration by partial fractions, part 1, I had explained what is a proper rational fraction and an improper rational fraction, and then progressed with the method for integration of a proper rational fraction using partial fractions. Today we shall understand the method of integrating an improper rational fraction. For the sake of convenience, I shall again explain in short the concept of proper and improper fractions. If we have a rational function p of x divided by q of x in which the degree of the polynomial at the numerator is less than the degree of the polynomial at the denominator, then the rational function is called a proper rational fraction. Otherwise, it is an improper rational function. Therefore, the rational function 3x minus 2 divided by x minus 2 whole square. Here, the degree of the polynomial at the numerator is 1 and that of the denominator is 2. Since the degree of the polynomial at the numerator is less than that at the denominator, this is a proper rational fraction. Now let us consider another. If we have x cubed plus x plus 1 divided by x square minus 1. Here the degree of the polynomial at the numerator is 3 and that of the denominator is 2. Since the degree of the polynomial at the numerator is not less than that at the denominator, this is an improper rational fraction. When we get a sum to integrate an improper rational fraction, our first step should be to reduce it to a proper fraction by the long division process. When we do that, the improper fraction can be rewritten in the form p of x divided by q of x is equal to t of x plus p1 of x divided by q of x. Here t of x is a polynomial and p1 of x divided by q of x is a proper rational function. The proper rational fraction p1 of x divided by q of x is thereafter rewritten as a sum of simpler rational fractions by the method of partial fraction decomposition. Though I have explained the forms of partial fractions in the last video, integration by partial fractions part 1, I shall reproduce it here for the sake of convenience. Children, we must be clear of the forms of partial fractions. This will make it simple for us to solve the problems. Now, we will solve a few sums on integration of improper rational functions so that we are able to understand the process. Yeah, the first sum that we have is I is equal to x square plus 1 divided by x square minus 5x plus 6. Yeah. Okay. We'll first reduce this improper rational function to a proper fraction by the long division method. I'll explain this in detail since many children have difficulty in long division method. Okay. Now I'm going to use the long division method. Now the numerator I write it here as the dividend So the dividend becomes x square plus 1, right? And the denominator becomes the divisor. So here I'll have x square minus 5x plus 6, right? Now we see that the term with the highest power of x in the divisor and the dividend. At the dividend it is x square, and at the divisor it is again x square. Therefore we do x square divided by x square. This is equal to 1. So this 1 I will write it as the quotient. Now I'll multiply every term in the divisor with this quotient. So I'll get 1 into x square is x square, right? 1 into minus 5x is minus 5x. So I'll write it here. And 1 into 6 is 6. So I'll write it here. Right? Now, since this has to be subtracted, I'll change the sign of every term here. So this plus will become minus, this plus will become minus, and this minus will become plus. Right? So x square and x square will get cancelled. Now I'll write this 5x plus addition. So 5x now plus 1 minus 6 gives minus 5. So I'll write it here. Right? Now the power of x here is 1, whereas in the divisor it is 2. Therefore I cannot proceed further. So this is my remainder. This is my remainder, right? Therefore now I can write the improper rational function as, now this is x square plus 1 divided by x square minus 5x plus 6, right? This can be written as first the quotient, that is 1, plus the remainder divided by the divisor. Remainder is 5x minus 5, and the divisor is x square minus 5x plus 6, right? Therefore I will be equal to integral of 1 dx plus integral of 5x minus 5 divided by x square minus 5x plus 6. Now this is a proper rational function which we have learned how to integrate using the partial fraction in our last video. So I can write I is equal to I1 plus I2, right, where I1 is equal to integral 1 dx and I2 is equal to integral 5x minus 5 by x square minus 5x plus 6 dx. Now I1 is equal to integral 1 dx. This is equal to x plus c1, right? Now let us solve I2. I2 is equal to integral 5x minus 5 divided by x square minus 5x plus 6. This is a proper fraction and we rewrite it using the partial fraction decomposition. Now I rewrite it here. 5x minus 5 divided by x square minus 5x plus 6. We have to first check whether the polynomial at the denominator can be factorized. If it can, we must factorize it. Therefore, I can write this as 5x minus 5, and I factorize the denominator. So I get x square minus 2x minus 3x plus 6, right? So this will be equal to 5x minus 5 divided by x into x minus 2, and here I'll get minus 3, and I again get here x minus 2, right? So this will be equal to 5x minus 5 divided by x minus 3 into x minus 2. Right. Now rewriting using partial fractions. Therefore, this 5x minus 5 divided by x minus 3 into x minus 2. This can be rewritten as a by x minus 3, right, plus b in divided by x minus 2. Therefore, 5x minus 5 divided by x minus 3 into x minus 2 is equal to, I'll take the LCM here, I'll get x minus 3 into x minus 2, and here at the numerator I'll get a into, now since I've already got x minus 3 here, I'll get x minus 2 here plus b into, now I already got x minus 2 here, so I get x minus 3 here, right? Now since the denominator are the same, we can equate the numerators. Therefore, 5x minus 5 is equal to a into x minus 2 plus b into x minus 3. Therefore, this will be equal to ax minus 2a plus bx minus 3b. Okay, now I take the coefficients of x, so x into a plus b, right, and I take the constants, I'll I'll get minus 2a minus 3b. Okay, now I compare the coefficients of x. Now, therefore, I'll get 5 is equal to a plus b. Therefore, a is equal to 5 minus b. This is my first equation. Now, I compare the constants. So, I'll get minus 5 is equal to minus 2a minus 3b. Now putting the value of a here, I get minus 2 into 5 minus b minus 3b. So this will be equal to minus 10 plus 2b minus 10. This is plus 2b right minus 3b. Okay, so I'll take this on the right side, minus 10 on the right side. So I'll get minus 5 plus 10, that I'll get 5 is equal to, this is minus b. Therefore b is equal to minus 5. And a I'll get this as 5 minus of minus 5, that is I'll get a is equal to 10, right? So a is equal to 10 and b is equal to minus 5. Now let's solve further. Therefore now this proper rational fraction I can write as 5x minus 5 divided by x minus 3 into x minus 2. This will be equal to a, that is 10 by x minus 3, right, minus 5 by x minus 2. Therefore I2 will be equal to integral 10 integral 1 by x minus 3 dx minus 5 integral 1 by x minus 2 dx. So this will be equal to 10 log of modulus x minus 3 minus 5 log of modulus of x minus 2 plus c2. Therefore now, since I is equal to I1 plus I2, this will be equal to x plus 10 log of modulus x minus 2 plus constant c, that is equal to c1 plus c2. Now let us go to the next problem. Right, now the next is I is equal to integral x cube plus x plus 1 divided by x squared minus 1 dx. The degree of the polynomial at the numerator is 3 and at the denominator it is 2. Therefore, this is an improper rational fraction. Therefore, we will have to reduce it to a proper rational fraction by the long division method. Okay, now I have I'll write the numerator as the dividend. So I'll get here x cube plus x plus 1, and the denominator I'll write it as the divisor. So I'll get x squared minus 1. Right, now the highest power of x is x cube in the dividend, and at the divisor it is x squared. So I'll do x cube by x squared. This is equal to x, right? So I'll write here at the quotient, x as the quotient here. Now every term in the divisor I will multiply it with x and write it here. So x into x squared is x cube, right? Now x into minus 1 is minus x. Okay, now since I have to subtract this, I'll change the sign of every term here. So since this is plus, it will become minus, and this is minus, it will become plus. So these two will get cancelled. I'll get x plus x is 2x, and here plus 1. Now the highest power of x here is 1, and here the highest power of x as the divisor is 2. Therefore I cannot proceed further. Therefore now I can write this improper rational fraction as x cube plus x plus 1 divided by x squared minus 1 is equal to this quotient x plus the remainder, that is 2x plus 1 divided by the divisor, that is x squared minus 1, right? Okay, now I will start my integration. Therefore integral of x cube plus x plus 1 divided by x squared minus 1 is equal to integral of x plus integral of 2x plus 1 by x squared minus 1. Now I'll take this as I1 and this is I2. So I will get this is equal to I1 plus I2, where I1 is equal to integral of x dx and I2 is integral of 2x plus 1 by x squared minus 1 dx. Okay, now let's start with I1. I1 is equal to integral x dx. So this is equal to x squared by 2 plus C1, right? Okay, now let's start with I2. I2 is equal to integral 2x plus 1 divided by x square minus 1 dx. Now we have to check whether the polynomial at the denominator can be factorized. So now since it can be factorized, I'll write this proper rational fraction as this is 2x plus 1 by x square minus 1. This will be equal to 2x plus 1. Now since I know a square minus b square is equal to a plus b into a minus b, so this will become x plus 1 into x minus 1. Okay, now I will rewrite using partial fractions. Therefore 2x plus 1 divided by x square minus 1 is equal to a by x plus 1 plus b by x minus 1. Therefore this is equal to, taking the LCM, I get x plus 1 into x minus 1. Now here this will become here a into, since I've already got x plus 1, I'll get x minus 1 here plus b into, I already have x minus 1 here, so I get x plus 1 here. So this is equal to ax minus a plus bx plus b divided by x plus 1 into x minus 1. Right? Now, since the, okay, now this is equal to, right, okay, now since the denominators both in the left hand side, right hand side is the same, I can compare, I can equate the numerators. Therefore I'll get 2x plus 1 is equal to, right, is equal to x into a plus b plus minus a plus b. Now comparing the coefficients of x, comparing coefficient of x on both sides, I'll get 2 is equal to a plus b. Therefore a is equal to 2 minus b. Now comparing the constants, I'll get 1 is equal to minus a plus b. Okay, so this is a minus of 2 minus b plus b. So this is equal to minus 2 plus b plus b, 1. So I'll get 3 is equal to 2b. Therefore b is equal to 3 by 2. Therefore, 2x plus 1 by x square minus 1 can be written as a by x plus 1. Therefore, I'll get a is, okay, alright, find the value of a. A is equal to 2 minus 3 by 2. Therefore, a is equal to 1 by 2. Right? So, I'll get 2x plus 1 by x square minus 1 is equal to a by x plus 1. So, a I have 1 by 2 by x plus 1 plus b by x minus 1. So, I'll get 3 by 2 by x minus 1. Right? Now, I'll go to the next page. Okay. Therefore, I2 can be written as integral, that is, integral of 1 by 2 divided by x plus 1 dx plus integral 3 by 2 by x minus 1 dx. So this will be equal to 1 by 2 integral dx by x plus 1 plus 3 by 2 integral dx by x minus 1. So this will be equal to 1 by 2 log of modulus x plus 1 plus 3 by 2 log of modulus of x minus 1. Now, since I is equal to I1 plus I2, now I1 is equal to x square by 2, and for I2 I'll write 1 by 2 log of modulus x plus 1 plus 3 by 2 log of modulus x minus 1 plus c, where c is equal to c1 plus c2. Okay, fine. Now, thanks children. I hope you all have found this class useful. In the next video, I shall explain integration by parts. Please like, share and subscribe to the channel to view more informative videos. You can press the bell icon to receive notifications whenever I post a new video. You can put your questions in the comment section below or email me at dlpbhatnagar@yahoo.co.in. Thanks.